Financial Modeling, Topic 5, Advanced Topics in VBA, User-Defined Functions for Use in Financial Applications. Copyright Lou Gaddis. In this topic, we're going to try to learn the programming skills needed to write many of the financial programs we're going to use in this course. And specifically, we're going to look at the use of loops, conditional statements, and matrix operations. An excellent resource for this is Benninga's Financial Modeling text, chapters on arrays, user-defined functions, and VBA types and loops. So we're going to first cover dim statements, option explicit statement, debugging programs, data types, the use of functions and functions, for loops, nested loops, and then using arrays and manipulating arrays and creating arrays within VBA. First thing we'll do, let's look at this program CAPM. And the program is pretty simple. It calculates a market risk premium. Specifically, our market risk premium is just my RM minus RF. And then CAPM is going to be equal to the risk-free rate plus the beta, which is a parameter, times the market risk premium. Let's grab this data here. And I'm going to put it into Excel. So we know our test data here. We know that the CAPM should be equal to the risk-free rate plus beta times the market risk premium, where the market risk premium is defined as RM minus RF. So we know the answer should be 4%. So it's 3 plus half of 2, 5 minus 3. That'll give us 4%. So that's our test data. Anytime I do programs, I make sure I understand or calculate the answer for actually lots of different scenarios, so I know my program's correct. And then we'll grab our program. I'll go to Excel, hit Alt F11 or Developer Macro, and then I'm going to insert a module. And I'll paste my function in. So in this case, a couple things you'll notice is in the program, I create a variable within the program. That's called an internal variable. It's a variable created inside a function. This variable MRP would not be in use for other functions in your spreadsheet or worksheet or module. And then I use that variable MRP here, except I misspell it. So there's a typo in there. So let me show you what happens when you run this function. So I'm going to insert my function. User defined, CAPM, risk-free rate, market, beta, and you see that the solution is 3% and there's no error. So again, looking at this program, here's what is happening. It gathers RF, RM, and beta, 3, 5, and 0.5. Calculates market risk premium, 5 minus 3, or 2%. And then calculates CAPM. CAPM equals risk-free rate, 3%, plus the beta, 0.5, times MRC. However, MRC has not been defined, so it assumes you're creating a new variable called MRC, and any new variable starts off with a empty sets or a 0 in there. So it's basically taking the risk-free rate plus beta times 0. And what's scary is you don't get an error message. You just may use this program for years before you realize there's an error. So that's a major problem with using VBA. However, you can fix this problem by using something called an option explicit statement at the top of a module. Once you type option explicit at the top of a module, and you only type it once and it has to be at the top, every new variable, internal variable you create have to be declared using a dim statement. So let me show. We'll go back to VBA, and I'm going to put option explicit at the top of my module. Notice it turns blue. Now I'm going to insert that function again, and you get an error. Variable not defined. So anytime you create an internal variable in VBA, you're going to have to declare it using a dim statement and say dim MRP. So now I'm allowed to use it. And if you ever want to get out of this debugging mode, just hit the reset button. And now I'll put my function back in. I'm getting another error now. It says variable not defined, except it's highlighted MRC, and that's where you say, oh, I simply mistyped that. So let me make that MRP. I'll reset, and then I'll put my function back in, and you can see now it's correct. So option explicit is an optional statement placed at the top of a module. And if you put an option explicit, all functions must use dim statements for the creation of internal variables. And the big benefit is it catches many errors. I find about 50% of my errors are misspellings of variable names. And this will catch all of those. Another thing I want to cover is use of function types. So in our program, I could have written it this way. I could have said dim ARP as, say, integer. I could have declared capm as a double precision floating decimal. So whenever you have these as statements, what you're doing, you're specifying a data type. Notice as an integer turn blue, and as in double or as in single turn blue. They're reserved words. Now these are completely optional statements, and I generally do not use them at all, but I wanted to point them out to you because you'll see these in practice all the time. The main benefits of using any kind of data type is you can specify many kinds of data. Long, single, double precision, floating, currency, decimal, date, object, string, variant, and so on. The default type is variant with characters, which reserves the most amount of memory in your computer. So if you know that your variable is only going to be a, say, integer, you can only use 2 bytes of data versus 22. So it may allow you to run programs smoother. The other advantage people talk about is if you, say, have a type as a string, looking for, say, text or decimal or currency, it may help the reader of the program debug it. Generally, I do not use any of those statements. So I'll just take out the as statements. All right, so a couple things I'd point out. We've already covered them all, really. The one is whenever you're debugging a program, you get stuck, I'll hit the reset button to try after I fixed it. Second thing, I would generally use single quotes to comment. So I might start every function with this function computes and provide some detail. I may also tell the user that RF is the risk-free interest rate, entered as a decimal. So giving the users an idea of what's being input. Also, another way to help prevent errors in the first place is to put option explicit on the first row or first line of your module, and then that requires you to use dim statements. Lastly, always have a test solution to a problem. I would not write a CAPM program without knowing the solution, and then I would test it for, say, more variables. So, does my program work when I have, say, a negative beta? So you can just test things out and see that you get the same value each time. One thing I want to point out that we'll be using later in this course is using functions within functions. And I'm just going to show you a simple example here on the PowerPoint. Say I have CAPM, which has parameters RF, RM, and beta. CAPM equals risk-free rate plus beta times market risk premium. Now here, this says MRP, and then has parentheses, so it looks like a function, like I wrote a function up here. In this case, this MRP, RF, RM is calling upon another function in the same module. So I have a function called MRP, which is just RM minus RF. So as soon as the function gets to this point of MRP, it actually calls on this other function, calculates RM minus RF, gets the value, and then completes this function. So the benefit of having a function with a function, or breaking larger functions into smaller functions, is you have modular code. So for example, if I had a very complex formula that calculated, say, a geometric Brownian motion forecasted asset price next year, I would probably create a function within a function if I'm going to use that code all the time, and I'm prone to make errors in it. And then I can call upon it on many programs. Notice that when you call up internal or a program within a program, you do not have to use application dot like you do have to use when you use Excel's built-in functions. So again, if I wanted to use Excel, say, std evp function within a function, I had to do application dot. You do not have to do that when you refer to functions within functions. And now one of the major topics we're going to talk about is doing loops. Loops are helpful in programs because it allows you to do a calculation many, many times, hundreds of thousands of times if necessary. And there's many different looping structures. So looping in, think of a looping structure as a way to make a repeated calculation. And there are do while statements, there are do loop while statements, do until statements, do loop until statements, and the last one we're going to use for today are for loops. Many of these looping structures are done or are used when you don't really know how many times a calculation has to happen. So you might have a program that keeps doing a repetitive task until something happens, say an equality is reached or a value is reached. For loops are used when you know exactly how many times something has to be done. So let's look at this program. I'm going to grab this data, copy. I want to make sure I get out of PowerPoint here. And I'll paste that. Delete that program. So what we have here is a payment of $100 received 5 years in a row, that's N, and discounted at 10%. So we can make a calculation to calculate the present value of those cash flows. The present value of the cash flow would be, say, the cash flow, $100. I'll anchor that. So it's going to be equal to my payment. I'll anchor that with dollar signs. Divided by 1 plus my interest rate. Anchor that with some dollar signs. Raised to the first power. So the present value of $100 received a year from now is 90. And we can do the rest. And what you'll see is that the present value of a 5-year annuity of $100 a year discounted at 10% is $379. All right, summing up the values. Notice I can also use Excel's built-in PV function, where I put in the discount rate, cash flow, and number of periods. But let me show you how you could write a simple program to do this. So here's the program. It's called p-value, parameters are payment, N, and R. So I have function, function name, parameters. End function is the end of the last line of the function. And then all the work is done here in a loop. So in this case, we need to take 5 calculations. You need to take the present value of the first, second, third, fourth, and fifth cash flows. So I'd use a for statement. For I equal 1 to n. So I'm going to do a statement 1 time, 2, 3, 4, 5 times if I were to insert this function and tell it that the value of n is equal to 5. So how this is going to work, it's going to set for I equal 1 to n, it's going to set I equal to the first value you specified here, 1. And then do this calculation. P-value, which currently has 0 in it, is equal to P-value, which currently has 0 in it again, plus payment, $100, over 1 plus the interest rate to the I power, 1. So that's going to put in p-value 0 plus $90. And then it gets to the statement next I. Next I kicks the program back to the for statement, increments I to the next value. So now I is now 2. Then does the calculation. P-value equals p-value. Now p-value currently has the $90 in it. So p-value is equal to $90 plus 100 over 1.1 squared. So it's going to add the $82. So now p-value has $172 in it, and a little bit extra. Next I is incremented to 3. The default incremental value is 1. You could change that by using a for I equal 1 to n. Step 1 would just do the same thing, but you can have a different step. But I don't think I use this for any of my programs. So now I is equal to 3. P-value equals p-value, which currently has $170 some in it, plus 100 over 1 plus r cubed, which is 75. Next I sets I equal to 4, adds the fourth cash flow, sets I equal to 5, adds the fifth cash flow, and then once I gets to the value of 5, which is n, which was input by a parameter, the function then skips to the next line, which is n function. So when you see code of a loop for I, next I, and then a function name or variable name equal to itself, like p-value equals p-value plus, we call this simple code an aggregation routine, where it's going to aggregate a value. In other words, take 90, then add 82, and then add 75, and then 68, and then add 62. If I didn't have p-value in here, if I were to say take this out of the program, what would happen is p-value would take on the value of 90, then it would take on the value of 82, and then it's not going to add them up. So if I ran this program, when it was all done, what would be left would be $62, just the last payment. So let's take this program before I broke it, copy, go back to my Developer Visual Basic tab. I'll paste it up here, but below the option, it has to be below option explicit. If option explicit winds up in the middle of your module, it's not going to work. And I'll insert the function. Payment and R. Notice I'm getting an error, and the reason I'm getting an error is because I did not dim I. I didn't declare an internal variable, which I started, and I have the option explicit line. So I either need to dim I and then have it run, and it works. And the alternative would be to just delete the option explicit. And then I can delete the dim statement or leave it in, doesn't matter. Dim statements are fine, they never hurt a program. They're just required when you have option explicit. So now, again, I'll input the program and it works that way too. One common way to write aggregation or write any kind of function like this would to create a temporary variable called temp. So I'd say my function is p-value, payment n and r, set temp equal to 0, and then here's the same looping structure as up here. The only difference is I have it going into a variable called temp. So set temp equal to 0 for I equal 1 to n. Temp gathers all these cash flows, and in the last step I say p-value is equal to temp. So again, this is a very common way of doing this problem. I usually try to minimize the lines of code, but some people say that this might be a better way because p-value, the present value, only is the present value after it runs through the whole routine, adds up all the cash flows. So in this program, it just adds up all the cash flows in temp, and then when it's all done, you just say p-value is equal to temp. Either one of those will work. If-then-else statements and if-then-else-else-if statements are very common code for doing many financial applications. If you use if-then-else, you can either do it all in one line, if some condition, then some calculation, else some other calculation, or you can do it across many lines, if some condition, then next line, some statements, else if, then next line. But you have to be careful. It either has to follow this mechanism or this format or this one. For example, I can't just throw an else if up here, or I'm sorry, put a statement here and then an else if on the next line. It either has to be in this format or this. So here's a program, p-value 2. So p-value 2 takes our same problem except adds one more variable, end or begin. So a user has to either put in a E or a B. E means that this $100 is received at the end of the first period and then every period afterwards. In other words, the cash flow is received at the end of the periods. B would be, well, the first cash flow is received today, so, and then a year later. So B means the cash flows begin today. E means the cash flows start in 1 year, at the end of the year or beginning of the year. So our problem we just calculated was an end of year cash flow. Most cash flows we see are end of year cash flows in finance. So the first cash flow of 100 was received in a year from now, so the present value is 100 over 1.1 or 90. However, if this were a cash flow that begins today, at the beginning of the year, I've received $100 today and then receive another 100 every year later. So the present value of $100 received today would be just 100. So we could specify a program, p-value, that the user has to give it an E or a B. If this variable that I just defined, end or begin, is E, say input by the user is E, and then my program looks like the last program. For I equal 1 to n, p-value 2 equals p-value 2 plus payment over 1 plus r to I. So that's exactly the code in the last program. However, if the user puts a B in, so else if end or begin is equal to B, then there's a different calculation. So if the user were to put a B in, and say in the second case here, what we need to do is take the present value of cash flows where the first one is received today. So p-value 2 equals p-value 2 plus 100 over 1 plus r, and here's the whole trick, over to the I minus 1 power. So it sets I equal 1 to I is equal to 1 for the first loop iteration. P-value 2 has 0 in it, so it's equal to 0 plus $100 over 1.1 raised to the 1 minus 1 power. Since I is equal to 1, it's 1 minus, so that's raised to the 0 power. Anything raised to the 0 power is 1. So it's really 100 over 1, or 1.1 to the 0 power, which is 1. So it's a trick that the first cash flow gets discounted at 0. And then the second cash flow is discounted, which is actually 1 year from now. The second cash flow received 1 year from now. It's discounted at the 2 minus 1 power, or 1. So this is a trick to getting it to skip the first discount factor. And then I can have an else statement at the end. If you didn't get, so basically if the user were to mess up and put in Z instead of E or B, all right, if they give an E, it does this calculation. If they insert a B in here, it gives us this calculation. But I like to make sure I add one more piece of code, because I could have ended it here and just said else it's this calculation. But I'm going to say else p-value 2 equals input E or B. Now what that'll do is if someone would wrote Z in here as an input, or maybe even the word end and not the letter E, what the function will return is just a text that says enter E or B. So I believe it's good programming to never end an else if statement assuming that the user input the correct parameter. Because in this case, if they did not put in an E or B, you're telling them enter in an E or B. So I can take this program and let me add a parameter, E or B, and let's copy that format. And let's make this E. And I can insert my function here. Let me grab that program again. Copy. Let's put it in up here. And I'll insert that. Payment, number of years, interest rate, end or begin. And there's my 379. If I were to put a B here, I get 416 is the present value of an annuity that starts today. But if I were to put, say, Z, I get a message input E or B, kind of alerting the error to the user. So that's using if, then, else, else if statements. Next thing we'll talk about is something we've discussed earlier, and that is using matrix operations in Excel and using parameters which are a range of values. If I use a parameter that's a range of values, I'll usually tell the user by using a data type as range. That tells the user that the data, you may accept a range in there. So this function takes returns as range and weights as range and calculates the portfolio mean, which is an MMULT transpose of the weights times the returns. However, when using Excel's built-in functions within VBA, you generally have to use application dot. So I just can't write mmult, I have to say application.mmult. I can't just say transpose. I have to use application.transpose. So if I grab this program, copy it, go to VBA, I'll put it at the top of my module, and let me grab some data. I'll just grab that. And I'll put it over here. And now I can see that my expected return of a portfolio is a sum product of returns and weights. But I can also use matrix algebra and my code I wrote. Port mean. Ret was a parameter and it was as range, so I can use a range. weights were a range, so I'll use a range. And since this is using matrix operations, I'll enter it by hitting Control-Shift-Enter, and there's my 17%. So when using parameters which are more than one cell, I'll generally put as range. And when I'm using Excel's built-in functions, specifically mmult and transpose and others, I'll use application dot. The other thing we're going to do is we're going to create arrays within VBA, not just input them as parameters, but create arrays and output arrays. Arrays in VBA use row by column identifiers. So let's take a look at this program. This function is called PVX. It takes the present value of cash flows, where the user enters the cash flows as a range. So the parameter cash flows would be, say, these three values when the user inputs the function. And then the user will also put in a discount rate, say 10%. It's not shown here. And what this program will do will take the present value of any number of cash flows. The first thing it's going to do is they're going to count how many cash flows there are. So I'm going to show you another object in VBA. It's called the rows.count object. So the first thing, to calculate the present value of three cash flows, I need to know there are three cash flows because I need to set up a for loop to value each one of them. So the first thing I'm going to do is I'm going to determine how big the parameter was or is. So when the user enters, say, 3 cash flows, n equals cashflows.rows.count. So it's looking at the parameter cash flows and counting how many rows. So n takes on the value of 3 if the user enters 3 cash flows. It takes on 100 if the user were to, say, enter in a row, 100 rows of cash flows. So now I know I need to do 3 calculations. So I set for I equal 1 to n is equal to 3, and say PVX, my function name, is equal to PVX. Whenever you see variable equals variable plus, you know that's doing aggregation. So PVX is now equal to 0 plus, now here I'm referring to the first cash flow in the parameter which I brought into VBA. So this parameter which I brought in is a 3-row by 1-column parameter as input by the user. So cash flows 1, 1 would be the first row, first column of the parameter, $100 over 1.1, assuming the discount rate's 10%, to the first power, which will give us $90. Next I. That kicks it back up to the for statement. I is equal to 2. PVX equals PVX, so $90 plus cash flow 2, 1, which would be the 150, over 1.1 plus R to the second power. So it's going to add 23 to 90 and put it in PVX. Next I, and then it takes the last cash flow in which it's done. And the present value of these 3 cash flows is $100. So I can grab this function, just show it works, copy. I'll put it up top. And I'll grab that data. Well, I'll just write 100, 150, and 200. So let's do the cash flows. 100, 150, 200. And let's say the discount rate is 10%. I could insert this function over here, PVX, put in a range of cash flows and a discount rate. And there's our 365. Now if I put in another cash flow of, say, 500, I could then take the program and take the present value of these four cash flows, be 706. So anytime the cash flow gets larger because the user input a larger range, n gets larger, the number of rows, and it does one extra calculation. So rows.count is a powerful object in VBA that tells you how many rows are in a particular array. You can also use, say, cash flows or any parameter name .columns.count, and that'll tell you how many columns have been input by the user. Speaking of using arrays, you can also create arrays within VBA. So I'm not just bring them in as a function parameter. I'm going to create it within VBA and maybe even output an array using a VBA function. To create a VBA array in the program, you must dim and redim it. So you have to use two statements. So if I want to create an array, just call it array name, just any name. I'll say dim array name, open and then close paren. This tells it it's an array. Then, once I figure out how large the array is going to be, which usually is figured out in the program, I'm going to redim same array name and actually tell the program its dimensions, say 3 rows or 2 columns. One thing we have to be concerned about is in VBA, internal arrays, it uses an option base of or a base of 0. So in other words, if you were to create a 1-by-1 matrix, so if I redimmed a 1-by-1 matrix in VBA, you would think you just created a 1 row, 1 column, in other words, a single value. However, VBA uses a base of 0, so if you do a 1-by-1, you actually create a 2-by-2 matrix, because first row and column is row 0, column 0, and then row 0, column 1. So no one likes to work with that. So what I do on all my programs that I know I'm going to create arrays, I write at the top of the module option base 1. Option base 1 ensures that arrays look like the normal way we do it, with the row and column starting at 1. So let's take a look at this program. I'll copy it. I'll go to my Excel, Visual Basic. I'll put this at the top. Option base 1 again has to be at the top. If you have an option explicit, that could also be at the top, but both option base 1 and option explicit have to be at the top before any functions, and you cannot repeat them. So in other words, I can't have option base 1 and then repeat option base 1 here. So here's a program called prices to returns. The function parameter is prices. The user is going to highlight a column of prices. And what the program is going to do is going to actually create an array of returns, which would just be the P1 minus P0 over P0. So if there are, say, 5 prices, you'll get an array of 4 returns. And that's all the program does. I'm going to insert it here again across an array. So let me just grab this data here. I'll just grab that. Put it in a new tab, new worksheet. And I'll insert my program called prices to returns. Notice here, I just want to point this out, notice where it has a worksheet in FinMod 5. Since what this is the PowerPoint. Whenever you see a file name here, what's referring to is you could use programs that are built into other programs that are open, but it's going to give you the file name. So I always want to use just port returns and port mean right here, and not port mean within worksheet number or worksheet in FinMod 5. So this is actually the program in Excel in the PowerPoint. Oh, that's the wrong one. It's called prices to returns. Prices to returns. So here are my prices. Control Shift Enter. Control Shift Enter across this range. And what you see are these are the returns for the first period, the second period, third period, and the fourth period. Let's look at the program. Program creates a temporary matrix, just called it temp matrix. Open close paren, that tells it it is an array. It figures out how big the temp matrix, so the temp matrix is going to be this matrix of returns. And we know the size of this new matrix is going to be the same size as this one minus 1. So if you have 5 prices, you get 4 returns. So I'm going to figure out how many prices there are. N equal prices.rows.count will tell me there's 5 rows. There must be 5 prices. And then I'm going to redim temp matrix, which is going to be this. And I'm going to redim it as an n minus 1, 1. In other words, a 4 by 1. If this is a 5 by 1, this has to be a 4 by 1. So now I've created temp matrix, space for temp matrix in VBA, and then I populate it. For I equal 1 to 4, again, we only have to do 4 calculations, not 5. So for I equal 1 to n minus 1, temp matrix 1, 1, so that would be this first number here, is prices 2, 1, that would be this 150, second row, first column, minus prices 1, 1, 100, divided by prices 1, 1. Again, we're doing some row column identifier. So it's going to take 150 minus 100 over 100. That is the 50% return. Next I set equal to 2. Temp matrix 2, 1. So now we're going to fill in this number. Equals the third price minus the second price over the second price. It's going to do it again and again. Complete it. The for loop is going to do 4 calculations. And then we're going to put temp matrix into the function name of prices to returns. That's what allows temp matrix to become the function value. So this is a common code in which we're going to create an array with Excel, determining the size of the array once someone enters data. So if they enter, say, a 10-row set of prices, it'll create an array that's a 9 by 1, and then does the calculations using a for loop. And then here on my new matrix, temp matrix, I'm populating it by first putting it into 1, 1, next I, then 2, 1, 3, 1, 4, 1, 5. So it's putting it in here, 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 and here inside the VBA program. And then this is referring to the prices 1, 1, 2, 1, 3, 1, 4, 1, 5, 1. And then the tougher ones are when we create n by n matrices, not just column vectors or row vectors in VBA, but we actually can create n by n or r by c arrays. And what we're going to use is a nested loop. So let's look at this program here, prices to returns. Copy that. Go to Excel, Developer, Visual Basic. I'm going to put it up top. I'm going to grab some data. I'll just grab this data here. Click out of there. Go to a new sheet within my workbook and paste it. So what this function prices to returns 2 does, let me see, what's that name again? It's prices to returns to, prices as range. It allows you to take, say, 3 stocks for 12 periods and create 3 columns by 11 periods and get returns. So I'll input prices to returns to, Control Shift Enter. These are my returns. I'm going to make sure that looks right. I'm going to look at the minus 12 and 4, 5. Check my test data. Minus 12 and 4, 5. So my test data looks fine. So let's look how this program works. Function prices to return, prices as range. So we just have our function name prices to returns, and the user is going to input a array of asset prices in columns. We're going to dim a temporary matrix. We'll just call it matrix, not temp matrix. We can just call it dim matrix. So the matrix is going to effectively be this. All right, last time we called it temp matrix, but we're just going to call it matrix this time. We're going to figure out how big this new matrix is going to be. It's going to have the same number of columns as prices. So column C is equal prices.columns.count. So it's going to figure out how many prices there are, and then calculate how many rows there are. That's how many periods. And then we're going to set the number of rows to matrix to 1 minus the number of rows of prices. In other words, if the user puts in a 13 by 3, matrix becomes a 12 by 3. So I'm going to redim matrix R by 3. I'm sorry, 13 by 3. Oh, I'm sorry, what was that? It's actually a 12 by 3. Alright, so now I've created the right size of my matrix. That's going to become prices to returns. That's down here. And then here's where all the calculations are going to do. And this is a nested for loop. It's about as hard as it gets in our VBA programming. For I, for j, next I. Alright, this is very common code for populating a multi-dimensional array within VBA. I and j are row and column counters. So for I equal 1, j equal 1. So I is going to equal to 1 to r. That's our 12 returns. J equal 1 to 3. That's our 3 prices. All right, so it sets I equal to 1, j equal to 1, and does a calculation. Matrix 1, 1 equals the second price in the first column minus the first price in the first column divided by the first price in the first column. So it's going to take this price, and then it needs to put it here in the matrix I just created. So matrix 1, 1 gets the price appreciation of the first stock. Next j. Now the j is going to kick it up to this j statement here. So I is still equal to 1, but j is now equal to 2. Again, remember j is my column counter. So j is equal to 2, I is still equal to 1, matrix 1, 2, first row, second column. And what's going to tell it is to pick up this price appreciation, 44.85 minus 45 over 45, and then put it in matrix first row, second column. So again, matrix 1, 2 is equal to the next price. Next j, it's then going to pick up these two prices and calculate the return and put it here. So my inner loop of my structure, so it's 4i, 4j, next I. The j's increment the columns. So it sets I equal to 1, and then j equal to 1, 2, 3. Sets I equal to 1, and then loops j equal to 1, then 2, then 3, and it fills in the first row. It's now completed the third column. Then it kicks down here, next I. That increments the row. I is now equal to 2. J gets reset to 1. So what it's going to do now is hop down here and then set I again. So we got I equal to 2, J equal to 1, 2, 3. And then it's going to hop down again. I equal to 3, J equal to 1, 2, 3. So the way the program works, it does this, and just works its way down, setting the I equal to 1, J equal to 1, 2, 3. I equal to 2, j equal to 1, 2, 3. 3, 1, 2, 3. And it works its way down and calculates all the price returns. When it's done, after I was set equal to 12, which is 1 minus 13, the number of prices, it then just puts this matrix, which just created, inside prices return and returns the value. So this is a pretty powerful looping structure to calculate nested loops. So here's another program that uses almost the same code. This program accepts an array of returns. So my parameter are going to be, say, stock A, B, and C, returns over 12 periods. And it's going to create a covariance matrix by taking the covariance between A and B, and A and C, and put it here. Then B with A, B with B, B with C, and so on. So let's look at this program. Option base 1, again, that has to be at the top of the module. Make sure it's not repeated. If it's already there, you don't have to do anything. So I'll just take this, go to my developer tab, Visual Basic. So I have Covariance. And then here's the program. dim temp matrix. The new matrix, my covariance matrix, if there are 3 columns, has to be a 3 by 3. If there's 3 stocks, you have a 3 by 3 covariance matrix. So we're going to redim my temp matrix as a 3 by 3 because it figures out there's 3 columns when the user inputs a parameter of 3 columns and returns. And then for I, for j, next I. That's my looping structure. The only trick is figuring out whether it goes to n or some other value. And then Covariance, the function name, is equal to temp matrix that I'm creating right now. So here's the actual calculation. It sets I and j equal to 1, so it's about to do this calculation right here. Temp matrix 1, 1. It's equal to application.covar returns.columns1, comma, returns.columns1. All right, again, I and j are equal to a value of 1. Returns.column is a VBA object that allows you to do an operation on an entire column. So it's taking returns, which is a parameter, taking the first column and doing a covar function against the first column. Actually turns out to be a 1. Next j. I is equal to 1, j equal to 2. So it's going to do this value here. It's going to do the covariance of the first return against the second return and put it here. And then do the third. At that point, j is gone from 1 to 2 to 3. That's as far as it's going to go. Next I sets I equal to 2. And it's going to start doing this row. j equal to 1, 2, 3. That brings it across. Next I, that's the third row. J equal to 1, 2, 3. So this is allowing you to calculate a covariance matrix. A real simple assignment from this one is to actually calculate a correlation matrix. You really just have to change the word covar to correl and change the function name. A couple things to help you not get lost is make sure you use your Project Explorer. Common mistake, very common mistake, is to have the same function inside module 1, then you mistakenly insert module 2, 3, 4, and you have the same function name in 2 modules or the same function name in the same module, and it won't run because it doesn't know which one. So make sure you have unique function names. Say Covariance cannot be repeated anywhere else in this spreadsheet modules. Or you may have put it into sheet 1. So instead of inserting a module, it may, when you open up the developer tab here, it may just put you in sheet 1 and you paste the function in. So all I do is when I click on module 1, I'll look up and see, okay, this is where I'm working. This should be your spreadsheet. And then make sure your functions are here. So you make sure you don't want to write programs in sheets. If you have, just delete them out. Other common mistake is if you have an option statement, either option base 1 or option explicit, they have to be at the top and they can't be repeated. It doesn't matter which one goes first. One other thing comes up is you create a bunch of programs or functions and then when you use them in other worksheets and workbooks, Well, the functions you create are attached to a workbook. When you save the workbook, it saves it. Make sure you save all functions, all workbooks that contain functions as a workbook-enabled or a macro-enabled workbook. If you do not save it as a macro-enabled workbook, it'll delete all your modules out. But a common trick would be to say, take a blank workbook, call it book 1 or whatever you want to call it, put every function you've ever written in it, and have some comments to tell what they do. And then whenever you open up a new workbook, make sure you start from, say, book 1, which you know contains all your functions. So effectively, you create kind of your own workbook that has all your functions, kind of a toolbox. As you attempt the assignments, this is a good place to start. A lot of the programs I write look like one of these 3 programs, especially when they're dealing with arrays. Whenever you see a function that says for I equal 1 to n next I, or for something equal for next loop, and you see a function name equals function name plus, that's the basic code for writing an aggregation function, whether it's doing present value of cash flows or annuities or valuing a bond. Anything that's going to keep adding an aggregate value, it's going to have a structure that looks like this. One loop and some function name equals function name plus. If you have a function that creates an array, specifically a column or row vector, not a multidimensional, but say a 3x1 or a 1x3, you're going to give it a name, give it some parameters. Make sure you do option-based 1 in front of all these ones where you create arrays. You're going to dim a temp matrix or matrix, give it no parameters, figure out the size, which usually is based on the size of a parameter, redim it, and then do, if you're just creating a row or column vector, have a for statement where you populate the values in here, and then give the function name the value of whatever is in the function here. So if you see a program where you know it's creating a row or column, the easiest thing to do would be to say copy this code, give it a unique name, and try to figure out exactly what that row or column vector is going to look like. And if you're creating a multi-dimensional array, top code looks about the same. Dim, redim. Except in this case, you're going to have 2 dimensions. Here it was either an n by 1 or a 1 by n. And you're going to have for I, for j, next I, and temp matrix is equal to something. This is going to populate a multi-dimensional array, and then give it the function name takes on the temp matrix. And you input these functions by using Control-Shift-Enter. So hopefully I've given you some skills you can use to work on all the programs we're going to use for the rest of this section on financial modeling.